Alrighty, let's get to work here on week 5. We're almost there, just a couple more weeks to go. You guys, for the most part, have been doing really well with getting all these assignments in, working your way through these different lessons, working with equations. Next evolutionary step with equations is, as you see here, two-sided equations. If you were able to follow the steps, if you were able to work your way through the multi-step equations where you had to simplify and then solve, this really shouldn't be a problem for you at all. Your biggest challenge here is keeping straight your path that you're going to take. Because what this means is this has a variable on both sides. Okay, so you're going to start off a problem that's going to have a variable on both sides. Obviously, we need to get them all to one side before we can solve. So what we have to make sure happens, very important, all terms with a variable, variable, not bell, must be moved to one side. At the same time, or following, doesn't matter, all constants must be on the same side. Once you've done that, then all you have to do is deal with the coefficient. So the adding of the inverses is what's going to move things from one side to the other, as you have already seen. So an example of this, jump right into this, and I wish I brought some examples with me. So we're going to end up with some fractions, I pretty much guarantee it. 4x minus 1 equals 5x. All right. Now notice we have a variable on this side and a variable on this side. Now again, your biggest challenge here is keeping yourself organized. Once you figure out a path you're going to take, you have to stick to it. I do this by drawing a line down the middle. This forces me not to move my equal sign around. That is a very common error made when we get into these things. I also make a decision on if or where I'm going to put different things. This side I'm going to make for my variables. This side is for my constants. Okay. Now, this one, I had something help me make that choice. There was no constant over here. So why would I put the constants on this side? It doesn't matter. So this is the only constant. Might as well leave it alone. That means this 4x, this term with the 4 is in the wrong spot. We need it on this side. So just as we have been doing over and over here, we are going to add the inverse. This entire term, it's a positive 4x, we put a negative 4x, and we put it on both sides. Now when we come across and we combine, look here, these make 0, leaving me a negative 1 equals positive 5 and negative 4 is 1x. This I can make invisible, so it would just be negative 1 equals x. There's our answer. Okay. Do another one here for you. Let's see here. Let's do example. And we'll do negative 3x plus 12 equals negative 7x. Well, I'm going to do my organization. I want to make sure that I pick a path and I follow it. And my path that I'm going to do once again, since there's no constant on this side, since this is the only constant, I'm going to make this side for my constant. This side only has variables, so I'm going to make it for a variable side. This negative 3x term is in the wrong spot. So I'm going to, you guessed it, add the inverse. So positive 3x, positive 3x. Whatever you do to one side, you do to the other. These add together to make 0, so they cancel each other out. I'm left with a positive 12 on this side. Equal sign stays on the line. This is a negative 7. This is a positive 3. They are different signs. Since they're different, we're going to subtract. 7 take away 3 is 4. There's more negatives, so I get a negative 4x. And now I need to divide by the coefficient. I need this x to be alone with a positive 1 coefficient. 4 divided by 4 is 1. Negative divided by negative is positive. That's how I can get an invisible positive 1 right there. But if I divide that side, I also have to divide this side. So I get negative 3. Positive divided by negative is negative. 12 divided by 4 is 3. Okay. Now, these two I gave you specifically to start with because there were certain things to help you pick your sides. The fact that there was no constant on this side made it very logical not to make this side for the constants. However, there comes problems that you will see in your assignments here where you may end up with a variable and a constant, a variable, let's do 5x, and a constant, let's do minus 15. So now look at our problem here. There's nothing to dictate where I put my V and where I put my C. It doesn't matter. Does not matter at all. You get to make some choices here. Actually, there's a few different things where you get to make choices with these problems. I could make this side variable and this side for the constant, or vice versa. It doesn't matter. I'll do this side for the variable. So I'm going to put a V up here. And notice I'm putting it right above the variable. Help me remember that that one is protected, basically. We're going to keep that there. That means this side is going to be for the constant. That's this one right here. So what I can identify really quickly here is that this positive 5 is a constant. It's in the wrong spot. It doesn't belong on that side because it's not a variable. This 5x has a variable. It's not on the right side because it's not a constant. Those two terms are the two terms that we're going to have to add the inverse of to get rid of. I'm going to break it down into 2 steps. I'm going to get rid of this 5 first. So I'm going to put a negative 5 and a negative 5. Break this across here. This 3x is just going to come down. These two cancel. Here's my equal sign on the line. I haven't done anything with the 5x yet. These two are the same. Since they're the same, I'm going to put them together. They stay negative, and I'm going to get negative 20. I still got this 5x. I highlighted it to remind me it's on the wrong side. So I'm going to put the inverse of negative 5x on both sides. And let's see, when we put these two together, they're different signs, so I subtract. There's more negatives, so this will be I'll bring this down here, negative 2x. These cancel, and a negative 20. Once you're done moving everything from side to side and side to side, it will always be the same thing. You have one term on one side with the variable, and one constant on the other side. If you have anything more than that, you're not done moving stuff yet. All of this adding the inverse is just sorting things out to the proper sides. Now, our final step, deal with that coefficient. -2 divided by -2 is +1. -20 divided by -2, negative divided by negative is positive. 20 divided by 2 is 10. And you're starting to see why understanding how to show you add the inverse. How to, again, add the inverse. How to show your work for dividing the coefficient. Why it's so important now, because you're not looking at that at the beginning of the problem and know that the answer is going to be 10. And this was a relatively easy problem, so even if you were able to look at it and know the answer was 10, it's not going to be that common. Okay, you're going to have to take your time with each problem, go through them, watch this problem a few more times. In fact, I'm going to do it one more time. I'm going to reverse the sides. I'm going to do the exact same problem. 3x plus 5 equals 5x minus 15. This side, when I draw my line, I'm going to make this side for the constant and this side for the variable. That means the things that are on the wrong side now are this 3x, because it is not a constant, it has a variable, and the -15, because it's a constant, it does not belong on the variable side. I'm going to add my inverses. -3x, -3x. Those cancel, leaving me a 5. Different signs, I'm going to subtract. I'm going to get 2x. And I still have to deal with that -15. So add the inverse. These two cancel out. I'm left with 20 equals 2x. Notice the similarities between these two problems. The numbers are all the same except for that up here that the 2x was negative, over here it's positive. That's because it flips sides. The 20 up here was negative, down here it's positive. I took this problem and all I did was flip it over. And when you do that, you change the signs. This is just showing you that it doesn't matter which method you use, because again, now that I divide by the coefficient, I'm going to get x equals 10. It's the same answer. Okay, it doesn't matter. You still get +10, +10. It all works out at the end. It doesn't matter which way you take it. All right, so see what you're going to do with these ones. Again, as you've been doing, ask questions if you need help. Let me know what you need. Email me, comment or something. Please stay in touch. This has been a very long time. Have a good week. Hopefully you all were very good to anybody that you could honor today on Mother's Day. Hopefully you had somebody that you could work with there. All right. This is Mr. Christensen ending week 5, and I will return next week for our next fun and exciting video. Goodbye.